Hello all, myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we'll learn about the basic concepts of algorithm, pseudocode and flowchart along with the definition and with some examples. So here, first coming to the definition of algorithm. So it is defined as, it is nothing but a step-by-step procedure or set of rules designed to solve a specific problem or perform a particular task. So in order to solve any problem, so we need to define it. So when we define the problem solution in terms of step by step, when the problem solution consists of finite number of steps along finite number of steps, so that is called as an algorithm. So algorithms, so they are used in not only computer science but also in other fields also. So wherever we have problem solving, so there we implement the concept of algorithms. So these are used in various fields such as computer science, mathematics and problem solving in general. So this is how you can summarize the definition of algorithm. It is nothing but a step-by-step procedure or set of rules which are designed to solve a specific problem or perform a particular task. Now let us see the properties and characteristics of algorithms. So when you're designing an algorithm, so before writing the program, so first which comes into picture is the design phase. So before writing the programs, so there is designing phase. So when you are implementing any software, first comes the design phase, then comes the implementation phase. So in the design phase, we have algorithms, we define the algorithms, and then in the implementation phase, we write the actual program. So here we write the program. So this program is written in any programming language. It requires a particular language to be written, Next, in the design phase, we write the algorithms. So this algorithm comes into picture in the design phase, whereas in the implementation phase, the programs, they are written based upon the algorithm which is designed in the design phase. So in order to solve any particular problem, we need there are certain characteristics and properties of algorithms. So these are the properties of algorithms. First we will see the properties and then we will see the applications of algorithms. So first is algorithm should be well defined. That means it should not be ambiguous. So any statement in the algorithm should not be ambiguous. It should be defined clearly. It must be precisely and clearly defined with clear and concise instructions for each step. So there should not be any room for interpretation or ambiguity. So there should not be any ambiguity in the steps which have been written in the algorithm. Next one is input. So algorithms take 0 or more inputs and produce at least one output. So the input specifies the initial state of the problem and output represents the solution or result of the problem. It is nothing but output is the result or the solution you can expect. Next one is finiteness. The algorithm should have finite number of steps. So therefore, in order to solve a problem, the problem solution must exist finitely. Algorithms must be finite, meaning they have a specific number of steps and eventually halt, that means stop, after producing the desired output. So the program or algorithm should not run indefinitely. So this is one of the most important characteristic of an algorithm. It should be finite. So that means there should be finite number of steps in the algorithm. Next one is effectiveness. So what is effective means? It should be able to solve the problem for which it has been designed for, using finite number of steps and resources. Next one is deterministic. So deterministic means it should give the same input and starting conditions. So given the starting conditions and input, the algorithm should produce the same output. So if it is producing some other output for the same input and starting conditions, then we cannot say that the algorithm is deterministic. Next one is correctness. Algorithm must be designed to produce the correct output for all possible inputs. So that means it should give the correct output for all possible inputs for which it has been designed for. So it should solve the problem it is intended to address. Next one is feasibility. So algorithms should be feasible. That means they can be implemented by using the existing technology and resources which are available. So they should not rely on, algorithm should not rely on theoretical or impractical assumptions. Next one is optimality. So algorithm should take into consideration optimality. That means it should produce the best possible result based on specific criteria or condition given, such as efficiency, taking into account the efficiency, speed or resource usage. So there is a concept called as algorithmic complexity. So, or design issues of an algorithm. Algorithm is said to be efficient only if it satisfies. So there are some certain constraints, some complexities to be taken into consideration, that is time complexity, and next one is space complexity. Time complexity and next one is space complexity. So what is time complexity and space complexity? We will see in the coming slides. Next one, let us see the applications of algorithms. So these are the different algorithms. Applications, they find there are wide variety of applications for algorithms. For example, in wide range of domains and industries, due to their ability to provide systematic and efficient solutions to various problems. So for example, one of the application is search engines like Google. So they use sophisticated algorithms for information retrieval. So for example, so there are many search algorithms available. So search engines like Google, they use these algorithms, sophisticated algorithms for information retrieval. Next one is sorting. So sorting is used in databases. So it is used in database, data analysis and various data processing tasks. So there also we have the concept of algorithms, sorting algorithms. Next, searching algorithms is used here. Next, sorting algorithms are used here. Next one is social network analysis, and then network flow optimization and recommendation systems. They use graph algorithms. Next one, optimization problems such as resource allocation and scheduling. They benefit from dynamic programming algorithms. So thus there are various algorithms. So algorithms, they find wide applications across a wide range of domains and industries. The next application is image and signal processing algorithms. So these are used in medical imaging, facial recognition and audio processing. So these are only some of the applications which are given. So there are wide variety of applications. So now let us see the efficiency of an algorithm. So algorithmic complexity, it is often referred to as time complexity and space complexity. It measures the efficiency of an algorithm in terms of the resources it consumes. So an algorithm is said to be efficient. So when it satisfies two constraints or two complexities, time complexity and the next one is space complexity. Time complexity is a measure of the amount of time an algorithm takes to complete as a function of the size of the input. So that means the time required for the program execution in terms of the size of the input or the program, you can say, that is given by time complexity. Next one is space complexity. Space complexity is nothing but it is a measure of the amount of memory or space an algorithm requires as a function of the size of the input. So this is the definition. This is space complexity. It is nothing but the amount of memory or space an algorithm requires as a function of size of the input is known as space complexity. So generally, the algorithms with lower time and space complexities are preferred. So thus, the algorithm which has low time complexity and low space complexity, these two are preferred. Next one is pseudocode. So pseudocode is an informal way of programming description that does not require any strict programming language syntax or underlying technology considerations. So thus you can say that it is informal way of program description. So from the name itself, we can say that it is pseudocode. Pseudocode means false code. So with the help of this, we don't write the actual code, but it acts as a bridge between the algorithm and the programmer, or it acts as a bridge between the user and the algorithm. So it is used for creating an outline or rough draft of a program. So after the algorithm has been designed in the design phase, so programmer can implement the actual program with the help of first by developing a pseudocode for the given algorithm. So it is a high level description of a computer program which uses a mix of natural language and simple code like syntax. So in order to write the pseudocode, we don't require any programming language syntax, or rules and regulations need not be followed. So it can be written in natural language and simple code like syntax. So it is designed to convey the logic and flow of a program without adhering to the strict syntax rules of a particular programming language. So let us see one example for pseudocode. So this is a simple pseudocode to check whether the given number is even or odd. So in order to check whether the given number is even or odd, so first we need to, so this one is the first step we need to start, and then after that, so this is the message which needs to be printed on the screen. Then display, enter any number to check whether it is even or odd. Then we need to read the number. So after reading the number, so this read statement is nothing but like storing the variable name, storing the number value in some variable. Next, after that, we need to check the statement or condition. If number mod 2 is equal to 0, if this condition is satisfied, then display the number is even. Else, display the number is odd. So this is after this, this is the end of if statement. So if else block will come to an end. So after this, the last one is the stop. So in this way, we can write the pseudocode to check whether the given number is even or odd. So thus you can see that, so here no programming syntax is to be followed. So no programming language syntax is followed. So it is written in natural language only, or human readable language only. So it acts as a bridge between, so after the algorithm has been written, so we can write the pseudocode and then go for actual implementation of the code. So that is what the pseudocode is meant for. Next one is, you can see the difference between pseudocode and algorithm. So with the help of these two this example, suppose we need to find, suppose we have two numbers, A and B are two numbers, and find the largest out of them. So suppose there are two numbers A and B, so we need to find the largest out of this. So the basic condition which need to be checked is, if A is greater than B, then we know that A is greater. Else if this condition is false, then B is greater. So that is what we need to check. A is greater. So if A is greater, then A is greater. Else, if the condition is false, then B is greater. So let us write the algorithm for this, how we can solve this problem by designing the algorithm for this problem. So in order to design the algorithm, so first we need to write the start step. Then start input A and B. That means read the numbers A and B. After this, you have to check this condition. Is A greater than B? So if yes, if this condition is true, then A is larger than B. If no, B is larger than A. Then print the larger number. So at the end, you need to stop. Or you can write end here also. Next here, coming to the pseudocode. So you can see the difference between pseudocode and algorithm here. So here first start or begin you can write, then get the numbers A and B, or read the numbers A and B. Then you have to compare A and B. So in order to compare, we can use this relational operator. So if A is large, so you can assign this variable A to max variable. If B is larger, then max value will be equal to B. So here you have to take one more variable, max variable, so which is used to hold the largest value. So larger number is stored in the variable max. So at the end you need to stop, or end you can write. So this is how you can write the pseudocode for the given problem. So advantages are, so these are the advantages of writing a pseudocode. It acts as a bridge between the programmer and algorithm or flowchart. Flowchart we will see in the coming slides. Then it works as a rough documentation to develop the program. So before the actual program is developed, we can write the pseudocode for that and then go for actual implementation of the code. So main goal of pseudocode is to explain each line of the program, what it should do. So each line of the program, what it should do. So that is for that purpose only we are writing the pseudocode. Next one, flowchart. So coming to flowchart, it is a visual representation of sequence of steps for solving a problem. So first thing we have seen that in the design phase, we write the algorithm for finding the solution to a given problem. So the algorithm characteristics are, it is finite, so it is optimal, then definite and correctness. So these are some of the characteristics of algorithm. So similarly, so we can write the solution to a problem in sequence of steps in terms of visual representation. So that is called as flowchart. Flowchart, so for visual representation, we need certain set of symbols. So flowchart is a set of symbols which indicate various operations in the program. So for every process, so there is a corresponding symbol in the flowchart. So once we write an algorithm, its pictorial representation can be done by using flowchart symbols. So let us see the various symbols which can be used in the flowchart. So in order to indicate the start and end operation of the algorithm. So these are the symbols which we can use. So this is the start, or you can use this oval symbol also. And inside this you need to write start. So this oval symbol which is written, it indicates the beginning and end of the flowchart. So this indicates beginning and this indicates the end or stop. So this indicates the end of the flowchart. This one indicates the beginning of the flowchart. Next symbol we have is decision or test symbol. So decision symbol is diamond shaped. So this symbol is used to take one of the decisions. So decision symbol is diamond shaped. So whenever in the algorithm, whenever in the problem, if you need to take some decisions, then we need to use this diamond symbol. So depending upon the condition, decision block selects one of the alternatives. So there are, if the condition is true, if it is true, it will execute one set of statements. If the condition is false, it will execute another set of statements. So this is a decision block. Next one is connector symbol. Connector symbol, it is shown in the form of a circle. So whenever in the flowchart we have circle, so that is a connector symbol. Suppose the problem is very, suppose we need to solve a problem and it requires some n number of steps. And if these n number of steps, they don't fit in a particular page, then we need to they don't fit in a particular page. And if we are writing the flowchart for that, and if you are drawing the flowchart in some another page, then you can establish the connectivity between the two flowcharts by using this connector symbol. So it is used to establish the connection whenever it is impossible to directly join two parts in a flowchart. So whenever the flowchart is very big and if it does not fit in one page, then you can connect those two flowcharts by using this connector symbol. So quite often two parts of the flowchart may be on two separate pages. So in such a case, we use the connector for joining the two parts. So as you can see here, so this is the connector for connecting to the next block, and this is the connector that comes from the previous block. Next symbol is process symbol, or you can say computational symbol. So whenever in the algorithm or problem solving, so we need computation or we need to compute some values, then we can use this rectangle block. The symbol of process block should be shown by a rectangle. So it is used mainly for data handling and values are assigned to the variables in this symbol. So for example, you need to compute the value of z here based upon the values of x and y. So that is done inside this rectangular block. So this is the process symbol. And next one is, apart from this, we have input and output symbols. So input output symbols, these are given by parallelogram. They look like a parallelogram. So input output symbol is used to input and output the data. So in order to read the values, so we have this symbol. In order to display the values or produce the output on the screen, we have this symbol. So read x comma y. So it will read the values of x and y. Next symbol is the flow lines. So these flow lines determine how the process of problem solving goes. So direction of the flow, direction of the process or workflow process is given by these symbols. Next one is predefined process. So this is another symbol which is used in flowchart for predefined process, and this one is the other symbol which is used in flowchart when we are using for internal storage. So let us see one example flowchart. Suppose we need to find the square of a number. Suppose the programmer wants to find the solution for calculating the square of a number. We know that square of any number n is given by n into n. So let us depict this with the help of flowchart. So first you need to write, in order to indicate the mark, or in order to indicate the beginning of the solution to the problem, we need to write start. So inside this oval shape, inside this oval, next after this, so this is a flow line which is used to indicate how the process is, what is the next step in the process. So in the next step in the process is to read the number. So whenever you are reading the number, so this is input symbol is used. So that is a parallelogram is used. Next after this, the flow goes in this way. So the next step in this process is to calculate the square of the number. Suppose you read the number as n. So then in the next step you have to do the computation. So, or you need to write the formula here. So formula is nothing but n into n. So calculate the square of the number. So that is given by n into n. So this is written in this rectangular block. After this, this is the next step in the process is to display the number. So in order to display the result, whatever is obtained here, so that you have to display here. Next, the next step in the process is to end. So thus we have completed the problem of finding the solution to computing the square of a number in these many steps. So there are only 3 steps apart from the start and stop or end, you can see here. So this is how the flowchart can be drawn for the given problem. Or analysis of a problem, a solution to a problem can be found. So thus you can say that flowchart is nothing but visual representation of solution to a particular problem. So that is what we have stated here. Visual representation of sequence of steps for solving a particular problem is called as. So thus in this video lecture we have seen the definition of algorithm. So what is algorithm? So algorithm is implemented in design phase. So it is given in design phase itself. So it is given by in the design phase by the persons who have the domain knowledge. Next one is pseudocode we have seen. So pseudocode is false code. It acts as a bridge between the algorithm and the user. So before actually writing the program, pseudocode for the given algorithm can be implemented. Next one is flowchart. Flowchart gives visual representation, or you can say it is diagrammatic representation of solution to a particular problem. So it consists of various symbols. So by making use of these symbols, we can get the diagrammatic representation of a given problem. So thus in this way we have seen the various definitions of algorithm, pseudocode and flowchart in this video lecture. In the next video lecture, we'll see some more concepts of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.